a flow of execution. So interrupt is basically, so it will stops or it will halt the normal flow of execution and it will execute the some other special function. So that's we require an interrupt. Okay, so that is nothing but the interrupt. And then, so why we require interrupt means, so while you are doing normal operation, okay, so if anything want to do, okay, if any important operation or important functionality you have to do, so then we can use this kind of signal to stop that normal activity and we can carry out some special or some more important functionalities or operation. So in that case, so we'll use the interrupt concept. Okay, so that will basically stop the normal flow of execution and it will take care about the some special function. So that is the basic. So then here we are talking about the signal. So interrupt is nothing but the kind of signal, so that can be generated by internally or externally. So based on that signal, so we can go for the classification of the interrupt. Okay, so before entering into the classification of the interrupt, so we are talking about some methods of two methods of interrupt, so the ways of generating the interrupts. Okay, so there are basically two methods. So the first one is interrupt. Okay, so then second one is the polling. So we have polling method and the interrupt method. So basically the first one is the polling. Okay, so after that we have interrupt concept. So the polling method is nothing but what? So the processor will keep on checking the status of the interrupt or the interrupt signal. So while doing some other activities also. So that is nothing but the polling. So here, so it will doing the or it will execute the normal program. So while executing the program, so it will continuously checking the status of the interrupt signals. So whether it is required or any other hardware devices required in a service or not. So that will keep on checking the that state within the period of time or specified delay of time. So it will going to check the condition or state. So that is nothing but the polling method. So interrupt is nothing but what? Whenever other hardware devices required in a service, so then only this signal is generated. So that means, so this method is nothing but interrupt method. So for example, so just assume that, so you are order any something. Okay, booked any product on the Flipkart or Amazon. So just assume that you have booked one product. Okay, so you are very excited to see that product or to use that product. Okay, so we'll get in a message one day, you will get in a message, so today your product will deliver to you. Okay, so we'll get that message. So because of you are very excited, so if any vehicle pass through your home or in front of your home, so you are continuously going outside and you are checking whether my product is coming or not. Okay, so that nothing but what? That is the polling method. So you are continuously checking the state of that signal, or you are continuously checking that person or delivery person, so whether my product is came or not. Okay, so that is nothing but the polling method. So interrupt is nothing but what? So whenever, so you are freely working on your progress or something. Okay, you are doing some activities in your home or something else. Okay, so while doing that, so he will come and he will interrupt you. So by pressing the doorbell, right? So when the doorbell is pressed, so then we can came out and we can collect it. So that is nothing but the interrupt and the polling method. So basically here the polling will waste the processing time. So interrupt is nothing but it will utilize the time. So that is the difference between the polling and the interrupt. So we can classify the interrupt. Okay, there are two types. So two types of interrupts. The first one is software interrupt. And second one is hardware interrupt. Software interrupt is nothing but the signal that are generated internally, so that are called as an software interrupt. And hardware interrupt is nothing but the interrupt signal is generated by the external, so that is nothing but hardware. So that is nothing but hardware interrupt. So for example, the software interrupt. So let's say, so we already used the timer concept. Okay, so timer will generate an interrupt, so that is called as an software interrupt. So whenever the specified it will reach, the timer will reach us to the specified time count, so then it will generate an interrupt, so that is called as a software interrupt. And the hardware interrupt means, so these signals are generated by the hardware devices, your actual devices or physical devices. For example, so for software interrupt we already taken timer. Okay, another example, so just use the I will use the example for a flash drive, so that is called your pen drive. Okay, so when you insert pen drive into your laptop, so then so we'll get an error. Okay, so the hardware device is detected, right? So that is nothing but the software interrupt. When you are putting into any external device into your laptop, so then your OS will detect an interrupt from that hardware device. Okay, so then it will generate, or it will use it will display the pop-up window called, so new hardware device is detected. So that is also kind of software interrupt. Okay, so then in the software interrupts we will have the different types of interrupts, like exception handling. Okay, exceptions. Okay, so our system softwares. Okay, or system software exceptions. So these are the some kinds of the software interrupts that will generate an interrupt internally. So then hardware interrupt is nothing but what? So these interrupts are generated by the external devices. So when you are putting the when you are inserting your mouse. Okay, okay, sorry, so the flash drive is nothing but the hardware interrupt, sorry. Okay, so your pen drive, when you are inserting the pen drive into your laptop, so then that pop-up window will show the new hardware is detected. So that is nothing but the hardware interrupt, because of the hardware you are interfacing hardware into your laptop, so then it will detect. So that is nothing but the hardware. So software interrupt is nothing but internal. So okay, so when you are managing, you are running out of the memory space, so then it will show, it will pop up the window called, so the your spaces are low disk space. So that is nothing but the software interrupts. Okay, and hardware interrupt means, so by using any hardware, so like pen drive or your mouse, wireless mouse or wireless keyboard or printer, so all these things will cause an external interrupt to your laptop. So that are means of hardware interrupts. Okay, so then we have another two kinds of interrupts. Okay, so like uh, maskable interrupt. Okay, so maskable interrupt and non-maskable interrupt, basically NMI. Okay, so non-maskable interrupt. So maskable interrupt is nothing but the processor can ignore this interrupt signals. So that is nothing but the maskable interrupt. So whenever this kind of interrupt will generate a request, okay, so then your processor can preempt this interrupt, or it can easily ignore that interrupt. So that is nothing but the maskable interrupt. So non-maskable interrupt is nothing but, so it cannot be ignored by your processor. So that is nothing but the non-maskable interrupt. So here, so the non-maskable interrupt is the highest priority. Okay, so that because of the highest priority, it cannot ignore this signal. Okay, so and the maskable interrupt is nothing but the lower priority, so it can easily ignore or preempt by the processor. Okay, so this is the difference between maskable interrupts and the non-maskable interrupts. Okay, so for example, for maskable and non-maskable interrupts. Okay, so I will take the same example for the pen drive. Okay, so when you are inserting the pen drive, okay, after that, so it will display the pop-up window called, so if you want to scan this file. Okay, so ನೀವೇನಾದರೂ ಸ್ಕ್ಯಾನ್ ಮಾಡ್ತೀರಾ ಪೆನ್ ಡ್ರೈವ್ ಅಂತ ನಿಮ್ಗೆ it will ask, right? So this can be ignored by the processor, means so this can be ignored by you basically. Okay, ಸೊ ನಿಮಗೆ ಸ್ಕ್ಯಾನ್ ಮಾಡಬೇಕು ಅಂದರೆ ಸ್ಕ್ಯಾನ್ ಬಟನ್ ಎಸ್ ಅಂತ ಟೈಪ್ ಕ್ಲಿಕ್ ಮಾಡ್ತೀರಾ, ಇಲ್ಲಾಂದರೆ ನೋ ಅಂತ ಕ್ಲಿಕ್ ಮಾಡ್ತೀರಾ. ಸೊ ದಿಸ್ ಕೈಂಡ್ ಆಫ್ ಇಂಟರಪ್ಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ಮಾಸ್ಕೇಬಲ್ ಇಂಟರಪ್ಟ್. So you can accept or you can easily ignore. But so non-maskable interrupt is nothing but, so just assume that your pen drive is corrupted. Okay, so when you are inserting a pen drive into your laptop, so then it will ask please format your hard disk, or please format your pen drive. So that is nothing but the example for the non-maskable interrupt, because so it won't open so until you have to format it. Okay, so that is the meaning of the non-maskable interrupts. Then here so this is all about the interrupts. Okay, so interrupt and the types of interrupts. So these are the methods of interrupts, basically two methods, and these are the another interrupts in the classifications of interrupts. Okay, so maskable interrupts and non-maskable interrupts. So based on the priority, you can do the particular operation. So then coming to your Arduino. So Arduino board will support two types of interrupts. Okay, two interrupts so that are associated with the particular pins. Okay, coming to the Arduino. Arduino Uno board. Okay, so specifically Arduino Uno board so will support two interrupts. It supports two interrupts. So these two interrupts are associated with the pin numbers called the zero interrupt. First interrupt is associated with the second pin on Arduino board. Okay, second pin, so that is nothing but digital pin, and second interrupt is associated with third pin on Arduino board. Okay, that is the third pin, digital pin. So interrupt 1 is associated with the second pin, and interrupt 2 is associated with a third pin on Arduino board. Okay, so using these two pins, so we can generate hardware interrupts. So these are the hardware interrupts. So how you can generate the software interrupt using timers. So when the time is reaches to the specified count, so then it will generate an interrupt. So that is called software interrupt. So hardware interrupt can be generated by using these physical pins. So port pin 2 and port pin 3. Okay, so these are the pins, and so it will provide some inbuilt functions to control the hardware interrupts. Okay, so here we will discuss some interrupts. Here again, so you have to know about some two terminology called interrupt request. Okay, interrupt request and then ISR. So then interrupt vector table, IVT. Okay, interrupt vector table. Again we have, based on the ISR, so again we will divide it into two types: vectored interrupt and non-vectored interrupt. Okay, so these are all embedded with the interrupt concepts. Okay, so here interrupt request is nothing but what? The signal. Okay, so that is the signal that is generated by the hardware devices or internally the software applications. So that is nothing but the interrupt request. So that is basically a signal that will given to your microprocessor, microcontroller. So that is nothing but the interrupt request. And ISR is nothing but what? So interrupt service routine. Okay, interrupt service routine. So what that mean? Interrupt service routine means when the interrupt signal is generated, okay, when the processor will got interrupt request, so then what the processor has to do, so that will defined by your ISR. Okay, so the particular interrupt will have the particular ISR. Okay, if the particular interrupt is occurred, the processor has to do the particular operation, so that is decided in the ISR function. So basically ISR or interrupt service routine is nothing but it is a small piece of code. Okay, so it is a small piece of code executed by your processor. So small piece of code is nothing but you are written some set of instructions in that function also. So whenever the interrupt occurs, I have to carry some a special function. So that special function will be written with the set of instruction again. So that's why, so we call it as an ISR is nothing but the small piece of code. Okay. So and it will be executed or it will be called by the processor when the interrupt request is arises. Okay. And then, so what about the IVT, interrupt vector table? So when the interrupt request is generated, the address of the ISR, okay, the location of the ISR will be stored in this interrupt vector table. Okay, so like that, so you can make use of the interrupt vector table. So all the related information about the interrupt and interrupt service routine will stored in the interrupt vector table. Okay, so that means of the interrupt vector table and ISR mean. Okay, so interrupt service routine is different and the interrupt vector table is different. Okay, so the ISR will tells which operation has to do by the processor, and IoT is nothing but the way you can find out the ISR. Okay, or where it is. Okay, so that will be finding using the IVT. So interrupt vector table. So again, so we have some vectored and non-vector, vector and non-vectored interrupt. So vectored means, so when the interrupt is generated, okay, or interrupt occurs, so the processor will not searching for the address of the ISR. It will directly go for the ISR and it will execute it because the address of this ISR will be predefined and internally. So that is the meaning of vector. Non-vectored means, so the address of the ISR will not be predetermined. So that is the basic difference between the vectored interrupts and the non-vectored interrupts. So basically, so the ISR, the address of the ISR will be stored in the vectored interrupts. Okay, in the non-vectored interrupts, the address of the ISR will not be stored. So that is nothing but the vector and the non-vectored interrupts. Okay, so this is all about the interrupt concept. Now, so already knowing about the Arduino board will provide some interrupt pins. Okay, so that are 2 and 3. So then we will go for the inbuilt functions. So before going to the inbuilt function, again you have to know about some internal functionalities. So when you can generate an interrupt. Okay, so there is a way for generating an interrupt or interrupting your processor. Just say that, so internally, so the clock pulses, so this operation will be carried out using the internal clock pulses. Okay, just assume that this is your clock pulse. So this interrupt can be generated externally using 3 modes. Okay, in the 3 ways, so you can generate an external interrupt. So one method is, so rising method. Second method is falling method. falling method, and third method is change method or change mode. Rising mode, falling mode and change mode. There are three modes. So then what is mean by rising then? So we can consider rising mode and falling mode and change mode. So just assume that, so this is our clock pulse, okay. So whenever this clock pulse goes from low to high, okay, at this state, so this is called rising edge, okay. So this is called rising mode, okay. So the when the pulse, the falling mode is nothing but what? So the interrupt will be generated in the falling edge, okay. So rising edge, rising mode, the interrupt will be generated in the rising edge, okay. And in the falling mode, the interrupt will be generated in the falling edge. So that means the whenever pulse goes from high to low, so this method and this edge is called, or this time is called, so falling mode, okay. So at this time, so it will going to generate an interrupt. So then what is mean by change mode then? So while, so it will generate two interrupts with one cycle. So that means, so in the case of from low to high, it will generate an interrupt, and in this case also it will generate an interrupt. So this is the case, when the pulse goes from high to low, so in this case also it will generate the interrupt, and in this case also it will generate an interrupt. So this is called change mode, okay. So change mode, so this is rising mode and this is falling mode. So like, so we can generate the hardware interrupts based on these three modes: rising mode, falling mode and change mode, okay. So now the inbuilt functions called, so attach interrupt, so inbuilt functions, inbuilt functions. So the first we have to make this normal GPIO pin to interrupt pin. So we are going to do that. So using the inbuilt function, so that is called attach interrupt, attach interrupt. So this is the syntax for generating an interrupt or assigning the particular hardware to the particular pin, okay. So attach interrupt, so you have to provide the interrupt pin here. So interrupt pin, interrupt pin number, and next you have to give the ISR name. So ISR name. So after that you have to set the condition. So on which mode you are going to generate an interrupt. So like for rising mode, falling mode and the change mode. So you have to select the mode here. One minute. Build function. Attach interrupt. interrupt pin number. Just I'll write interrupt number, and next ISR name, then we have mode, on which mode we are generating an interrupt. Okay. So, and we have another syntax for making the pin 2 and 3 as an interrupt. So similar to previous one. Okay, the attach interrupt, same thing. Here, so we have digital pin to interrupt. Okay, digital pin to interrupt. Then ISR name and same mode. So these are the two types of functions. So you can use to initialize the pin number 2 and 3 as an interrupt. Okay. So in the first case, so we have to provide the interrupt number. So here we have only two interrupts. The number is okay from 0 to 1. Okay. So interrupt 0 is nothing but the second pin. Okay. Here I will write here. The second pin is nothing but what? Interrupt 0 pin. And interrupt 3 is nothing but, or pin number 3 is associated with the interrupt 1. Okay, so totally two interrupts, and 0 is associated with the pin number 2 and 1 is associated with the pin number 3. Okay, so in the second case, so directly you can mention the digital pin numbers. Okay, so attach interrupt digital pin to, okay, sorry, here this is make it as a digital pin to interrupt. So here we can provide the direct digital pin numbers like 2 and 3. So if you want to mention the digital pin directly, then go for second one. So if you are mentioning 0 and 1, so then use the first method. Okay. So these are the inbuilt function for interrupt controlling by the hardware. Okay. So now I will use the first condition. Okay, let's see the first condition how it will work. So after that I will use the second condition. Okay, so let me open my sketch. Okay. So just I will open new sketch. Okay. Just I will go for the first function. Here just I will control the LED, so based on the switch. Okay, so see here, so just I am using the switch as an interrupt now. Okay, so switch is an hardware device, so that is connected to your Arduino microcontroller. So whenever I press the push button, it will turn on the LED, and when it is released, so then it will turn off the LED. Okay, so just I am making for blinking an LED. So in the some applications, so we require an interrupt. So I will show you. So what is the use of interrupt in our normal programming? Okay. So first, so I will make this interrupt pin as an input. Okay. So our interrupt. So using the first function. Okay. So before writing the code, so just let's see the block diagram. Okay. So let's take your Arduino board and push button. So push button and register one LED. Okay. So connect ground to ground. Then this pin is connected to VCC. Then so this control pin is connected with any one of the control pin. Okay. Here I will take it as an 2. So now I will work pin number 2 as an interrupt. Okay. So then connect LED ground to ground and positive to 13 pin. So 13 pin. Okay. So this is a simple connection. So now this switch will act as an interrupt now. Okay. So when you are pressing this push button, it will turn on the LED. So when you are releasing this push button, so it will turn off the LED. Okay. So this is the connection, and I will go for the port. So first of all, I will make a digital pin 2 as an interrupt. So using the inbuilt function, so just I will use serial monitor, okay, for printing the status. Okay. Serial dot begin 9600 baud rate. Then I will make the pin number 2 as an interrupt 0. Okay. So for that we have to use inbuilt function called attach interrupt. Okay. Then here just I will give the interrupt number now. Okay. So there is the two ways, right? So just I will give the interrupt number. So what is the interrupt number for pin number 2? So 0. So if you are connecting this switch to pin number 3, so then make it as an 1. Okay. So now I will make it as a 0. So 0, and I will give the name as blink. Okay. So I want to blink the LED. So that is my operation. Blink is the ISR name, and give the mode. So mode you have 3 mode: rising mode, falling mode, and the change mode. So just I will use the rising mode. So now you are making the pin number 2 as an interrupt. Okay, pin number 2. So after that, so I won't use a while loop here because you are generating an interrupt. Okay, so if an interrupt is generated, so then it will not execute the normal program. So it will execute the special condition called ISR. So this is your ISR. So then I will create an ISR wide blink. Okay, so this is the ISR. So in that, so I'll write the code. So here, so I'll just print. Okay, this is initial stage. Just I'll print the information. Okay. So just I'll print serial dot print ln interrupt occurred. Okay, interrupt occurred. So this is the simple code for print. Okay, so we are printing the interrupt occurred function. So when the interrupt is occurred by the pin number 2, so using push button. Okay. So after that I will turn on the LED. Okay. So just upload this code. simulation. Tinkercad. Just take Arduino and breadboard. So then push button, register, LED, so ground to ground, and connect to this ground to ground on breadboard, and this is connected with 5 volt, and control pin is connected with second pin. So then this LED is connected with 13 pin. Okay, just I'll copy this code. Okay, so just I'll simulate the code. So you can see here the interrupt is offered. Okay, so now I press the push button, so interrupt is offered. So interrupt is offered. You can see here interrupt is offered. So now we are generating interrupt. So you can see here, you can check the program. So in the while loop there is no statement. Okay, it will contain no statement. Okay, so even though it will contain no statement, so then it will print serial. It will print the message interrupt occurred on the serial monitor. So because when the interrupt is occurred, so your processor will execute ISR, the particular ISR. So the particular interrupt request will have the particular ISR. So like this. Okay. So if the interrupt is occurred on the pin number 2, so then it will rise or it will execute, your processor will execute blink function. So this is your blink function. In the blink function we have written serial.print ln interrupt occurred. So now we can also change the code for turning on LED here. For that we have to use pin mode 13 comma output, and turn on the LED. So digital write LED comma 1. So after some times you can also turn off this LED, no problem. So just use delay, or every time you can also power it. Okay, so just use delay 100 and 0 and 100. So basically in the ISR routine, so we don't use delay normally. Okay, so just avoid the usage of the delay in the ISR function. So then we get an error. Okay, just missed semicolon. So then we have see here. One minute. You can see here the LED is blinked. So when the interrupter is offered, okay. So now you can see the actual usage of interrupt in our program. Okay. So if I am using this switch as a normal switch, okay. So just take, okay, let's see this example clearly, okay. So then you will understand, so what is the use of the interrupt in the embedded systems, okay. So just now I will use this interrupt in normal switch as a normal switch, okay. Pin mode, we have 13 as an output, and in the pin mode, again I will make the two pin as an input, okay. So now you have to, the second pin will act as a normal, okay. So input. So now I will do that. So first of all, digital write, thirteen comma high, and delay I will use 5 seconds, okay. I will use 5 seconds, and so again I will turn it off for another 5 seconds. So then I will use the switch, okay. So you can see here, first I will read the switch. So after that I will read the switch, I will check the status of the particular switch, okay. If digital read of which pin, the second pin, the second pin is equal to high, then I will turn on the LED, okay. I will print the another statement like serial dot println switch is pressed, okay. So when the switch is pressed, it will display switch is pressed, okay. So now we'll see so how exactly it will use the result, okay. So now I will comment this void function, okay. Okay. So see here, so this is our normal code. The second pin now will act as a normal switch. So now I will execute this code. So then error here. So digital write. So you can see, so the LED is turned on for 5 seconds and it will turn off for another 5 seconds, okay. So now I will show you what is the disadvantage of the normal switch. Now I will press the push button, okay. So okay, I will open my serial monitor. So there is no message, okay. Okay, switch is pressed, 1 minute, the digital read pin 2. Let's check the connection. So this is the usage of interrupt. Okay, so you can normally stop the normal flow of execution and we can carry out the some special functions. Okay, so now I'm pressing. Okay, just let me clear the screen. Okay, so now I'll press, so interrupt occurred. Okay, again interrupt occurred, interrupt occurred. Okay, so basically it will stop the normal flow of execution and it will execute this blink function. Okay, so this is the interrupt. So we are working the pin number 2 as an interrupt. So now, so this is the rising mode. So then I will show you the falling mode. Okay, falling. So now start the assembly. So now, so in the release time, it will generate an interrupt. Okay. So when the pulse will goes from high to low, so then only it will generate interrupt. So now I will press the push button. So it is not generating any interrupt. Now I will release. At this time, it will generate an interrupt. You can see here. So interrupt occurred. So now again I will press the push button. So it is not generating any interrupt. So now I will release. So then it will generate an interrupt. So this is nothing but falling interrupt. Okay. So that means the transition from high to low. So then only it will generate interrupt. So that is nothing but the falling mode. So now we will see change mode. Change mode. Okay. So now we will generate two interrupts. Okay. So when the transition from low to high, it will generate interrupt. Again, when it will detect the transition from high to low, so again it will generate an interrupt. So now you can see, so interrupt is generated. Now I will release the push button again. It will generate an interrupt. Okay. So you can see here. So actually you are generating two interrupts when switch is pressed and released for one time. Okay. So pressing, it will generate. Okay, so now I'll press, it will generate an interrupt. Again I will release, again it will generate an interrupt. Okay, so like that. So you can also use the mode. So if you want rising mode, so you can also you can use the rising. Okay, so if you want to generate an interrupt in falling mode or on the release time, so you can use falling mode. So if you want to generate interrupt at the both cases, so then go for the change mode. Okay. So this is about the interrupt concept. Okay. So now, so I will change the, I will toggle the LED when the switch is pressed. So that is also you can do. Okay. So just or simply in the while loop you can also use the serial monitor. Okay, serial print. Serial dot println, this is loop statement. Okay, let's run this code. So you are getting error, the serial was not okay here. So once you open serial monitor, so it will keep on printing. This is loop statement. So now I press, so interrupt occurred. Okay, interrupt occurred. So basically it will stop the normal flow of execution and it will execute the interrupt functions, ISR function. Okay. So like that, so you can make use of the loop, while loop function also, and you can also use ISR function. Okay. So this is for one interrupt. Okay. So now we will see the another pin. Okay. So this is for the second pin. Now I will use third pin. Okay, for third pin you have to make it as an 1. Okay, So now I will execute. Okay, so just see. Okay, so now I will execute. So now I will press the push button. Okay, so it won't work because so it is connected with the second pin, right? So now we have to make it, we have to connect to this switch pin to third pin. Okay. So now I will press so interrupt offered. Okay, interrupt offered. Interrupt offered. So so this is the interrupt, external interrupt generating at the third pin. Okay. So just use second and third pin. So if you are using or mentioning other than these two pins, so it won't work or it won't work as an interrupt. Okay. So basically InnoBoard we come up with the two interrupts only that are associated with the second pin and the third pin. So this is the one way. Okay, so this is the first method. So attach interrupt, interrupt pin number and ISR name and mode. So then we have another, so attach interrupt digital pin to interrupt. Okay, so we can also use this function also. Okay, here. So just I will use here digital pin to interrupt. So here, so you can directly provide the digital pin number 2 and 3. So now you are using 3, right? So 3 and start the simulation. So you'll get same result. Okay. You can see here interrupt offer. Okay. So you can also connect it to second again, second pin. So here make it as an 2. So clear the command window. Okay, you can see here interrupt offer. Okay. So you can use anyone inbuilt function. Okay. The second one is so attach interrupt digital pin to interrupt pin. Okay. So now I'll go for the blinking LED code. Okay. To blink. So just use digital right. So in the previous case we already did for toggling the LED. Okay, right? So digital right. So 13 comma again digital read. Read of 13 XOR with the 1. Simulate the code. Okay. So because you are changing the you are in the change mode, so it will generate two interrupts at the same time. Okay. Okay. So just go for rising. Now you can see here it is turned on. Now again I will press, it is turned off. Okay. So now it is turned on. At the second time it will turn off. Okay. So like that, so you can use multi-functions in the ISR function. So you have any doubts in this interrupt programming? Okay, this is your simple interrupt programming. Just you have to assign the particular pin as an interrupt. Okay, so then you can do whatever you like. Okay, just by creating so the ISR function like this. So this is ISR function, and this is your loop main loop function, and this is your setup function. You guys have any doubt? So similar to the previous programs, so here I will use another statement for making the third pin as an interrupt pin. So I will take, so attach interrupt digital pin to interrupt is third pin. Okay, and here I will make ISR pin as an so different name. Okay, so I will call it as just okay here. Just I will control of a single LED for first operation. Okay, so here I will make LED on. Okay, LED on. The here ISR is LED off, and both are interrupt generated in the rising mode. Okay, so just change the name LED on. So here I will make it as on, and in the second function wide LED off, and here I will turn off the LED, same LED. So digital write 13 comma 0. So if the interrupt is generated from second pin, so it will turn on the LED. So if the interrupt is generated from the third pin, so it will turn off the LED. Okay. Start the simulation. So now you can see here the first switch is pressed, so then it will turn on the LED. So now I'll generate second interrupt on third pin, so it will turn off the LED. Okay. You can see here. No, like that, so you can do multiple operations. So here I will write blinking code or toggle code digital read of 13 pin. So this is the toggling code, and like that. So just use another pin for 12 pin. So 12 pin toggle. Make the pin number 12 as an output. And simulate the code. So it is controlling the first LED, the second switch will control second LED. Okay. So like that, so we can generate the two external interrupt using the Arduino microcontroller board. So if you want quick response from your controller, so while doing some other operations, so then you can make use of these interrupts. So then it will respond quickly. So because the interrupt has the highest priority than the normal program, so that's why it will respond to the interrupts immediately. Okay. writing ISR, so you have to know the following points. The first point is, so no use delays. Okay. Okay. We cannot use the delay in ISR functions. So then don't use serial pins. Okay. So now I am showing here the simple example. Okay. So in the larger application, or if your application will have the more number of lines, so then we may get the effect in the operation. So when you are creating the ISR with delays by printing more number of serial prints. Okay. So then we will get an so inaccuracy output. Okay. So the third point is when the your variable is shared between the ISR. Okay. So in the main program, so you use the variable, and the same variable can be used in the ISR. So then we have to make it as a boolean, non-volatile. Okay. Volatile variable. So then make a volatile variable. So then you can use that variable in the ISR function. Okay. So like volatile int a, so like that. Okay. So if you are using a variable in your main program as well as the ISR function, so then define with the volatile keyword. Okay. So these are the three main points. So while writing an ISR. Okay. Keep these points clearly. Okay. Note this point. So while writing an ISR, or while creating an ISR, so you don't use the delay and don't use serial prints, and make the variable as volatile when you are shared between the ISR function. Okay. So these are the points. Okay. This is all about the interrupt concept. Okay. So it will provide only two interrupts, nothing more than that. So if you want more interrupts, so then we have to choose the different types of Arduino microcontroller boards. So like Arduino Mega, so we get approximately 6 to 8 interrupt pins on the Arduino Mega. So like that, so based on the application requirement, so you can choose the particular Arduino microcontroller board.